Welcome to Nomis Academy. This time we'll be dealing with problems on combination, and we have a question to critically analyze and solve it. It's a question on combination. A university has 15 professors, 20 associate professors, and 25 assistant professors. A committee of 5 members is to be formed with condition Roman figure 1, at least 2 professors, 2 at most 2 associate professors, 3 at least 1 assistant professor. So in how many ways can we select out of what is available in the university to form a committee of 5 members? So what we're going to do is that we have cases for the condition given. What do I mean by cases? Because condition number 1 says at least 2 professors. That means we could have more than 2 professors to be selected in the committee. Condition number 2 says at most 2 associate professors. That says we cannot take more than 2 associate professors. That is, we could take 1, at most 2 associate professors. So the cases of 1 must be treated, and the case of 2 must be treated. At least 1 assistant professor. So since this is at least 1 assistant professor, we could have a case of 2 assistant professor, 3 assistant professor, or 4, depending on the number of the members that we want to take. Remember that all these conditions must be met. All these conditions must be met. So we need to state out the possible cases. So let's state out the possible cases by going into the solution. So solution number 1, at least 2 professors. So at least 2 professors. So out of 15 professors, here we are taking at least 2 professors. So if we're taking at least 2 professors, let's say case number 1, then we say that if we take at least 2 professors, let's say we take 2 professors, that means among 15 professors we will take 2 of them. Now it should be multiplied with other people we want to take. Remaining 3 people we should take, right? So out of 20 associate professor, let's say out of 20 associate professor, we pick 2 because we can at most take 2. So we pick 2, then multiply by, out of the assistant professors that we have 25, we could pick how many now? 1 to make our 5 members. So this is case number 1. So let's think about case number 2. Case number 2, since the question says at least 2 professors, so let's say I still take 2 professors, taking that condition, multiply by at most 2 associate professors. Let's say this time I decide to take 1 associate professor. 1 associate professor, that will be 20 combination 1, multiply by 25 assistant professors. Since I should at least take 1, then I can take more than 1. So to make up the number of members of the committee, I can only take 2 as this case demand. So case number 3. Now case number 3 says that at least 2 professors. That means I could take more than 2 professors, right? So let me see if I could take 3 professors. That is 15 combination 3. 15 combination 3 multiplied by, now I have just 1 left. So consider it carefully. At most 2. That means I could take just 1, and at least 1. That means I could just take 1. That means the conditions are still met. So I can say 20 combination 1 multiplied by 25 combination 1. So these are the 3 possible cases that can come up in the selection of this category of people in the university to form a committee of 5 members. So what are we going to do now to know the number of ways that we can do the selection? So we are going to do for each case and then add up the ways for each case together to get the total number of ways that we can select these 5 members of a committee among the 15 professors, 20 associate professors, and 25 assistant professors in the university. So let's go on to one. So case number one, case one. Case one says 15 combination 2 multiply by 20 combination 2 multiply by 25 combination 1. So let us begin. Remember the formula of combination. Let us remind ourselves here. So n combination r is equal to n factorial all over n minus r factorial r factorial. So remember this formula. This formula is going to guide us to solving each of these parts of the combination. So this becomes 15 factorial all over 15 minus 2 factorial 2 factorial multiplied by 20 factorial all over 20 minus 2 factorial 2 factorial multiplied by 25 factorial all over 25 minus 1 factorial 1 factorial. So here we have 15 factorial all over 15 minus 2 is 13 factorial multiplied by 2 factorial, then multiplied by, here we have 20 factorial all over 20 minus 2 factorial, that is 18 factorial multiplied by 2 factorial multiplied by 25 over 25 minus 1 is 24 factorial. So 1 factorial is just 1, so we can leave it. So we can then begin to express our factorial quantity. So this is 15 multiplied by 14 multiplied by 13 factorial. To avoid long notes, we can just stop here since I have a common factorial as the denominator to divide it. So I can just have 13 factorial multiplied by 2 factorial is 2 multiplied by 1 multiplied by, so the same thing here, 20 factorial is 20 multiplied by 19 and then multiply by 18 factorial, right? So I can stop there. I say divide by 18 factorial multiply by 2 times 1. So the third part equal to 25 factorial, that is 25 times 24 factorial all over 24 factorial. So I can easily say 13 factorial cancel 13 factorial, 2 here 1 and then 2 here 7. So I'm left with 15 multiplied by 7 here, and here I can say 18 factorial cancels 18 factorial, 2 here 1 and then 2 here is 10. So I'm left with 10 times 19 here. Now multiply by 24 factorial multiply 24 factorial. So I'm left with 25 here. So 15 times 7 is 105, right? Yes, 105. Multiply by 10 times 19 is 190. 190 multiply by what we are left here is 25. So we are left with 105 multiplied by 190 multiply by 25. So when we multiply all together, oh this boy, get yourself out of that place, Gary. Spoil my video for me now. If you're gonna throw it in the fan, so you even get money. So we have 105 multiplied by 190 multiplied by 25. So let's get down to business to calculate the value of this. 105 multiplied by 190 multiplied by 25 is 498,750. So this is 498,750 ways. So in this case, if we consider this case, we are going to have this number of ways of selection. So let's consider case number 2. So case number 2, case 2 says that 5 combination 2 multiplied by 20 combination 1 and 25 combination 2. So 20 combination 1 multiplied by 25 combination 2. So we are still forming our 5. So let us go in that minus 2 factorial multiplied by 20 factorial all over 20 minus 1 factorial multiplied by 25 factorial all over 25 minus 2 factorial and then 2 factorial. So this becomes 15 factorial all over 15 minus 2 is just 13 factorial. So 13 factorial multiplied by 2 factorial. So now multiply by 20 factorial all over 19 factorial. 1 factorial is just 1. Then I have 25 factorial. 25 minus 2 factorial, that's just 23 factorial. 23 factorial multiplied by 2 factorial, right? 2 factorial. So here I can just express it to be 15 times 14 times 13 factorial. So all over 13 factorial, 2 factorial, multiplied by 20 multiplied by 19 factorial, all over 19 factorial, multiplied by 25 times 24 times 23 factorial, all over 23 factorial, multiplied by 2 factorial. So I can simply say 13 factorial cancel 13 factorial, and 2 factorial is just 2, 2 here 1, and then 2 here 7. So I'm left with 15 multiplied by 7 here. 19 factorial cancels 19 factorials. I'm left with 20. Yeah, just 23 factorial cancel 23 factorial. So 2 factorial is just 2, 2 here 1, and then 2 in 24 is 12. So I'm left with 15 times 7. This is 105 multiplied by 20 multiplied by 25 multiplied by 12. So we have 105 multiplied by 20 multiplied by 25 multiplied by 12. The answer is 630. So this is 630,000 ways. So there are 630,000 ways this can be done. So let's consider case number 3. Case 3. So case 3 says 15 combination 3. So 15 combination 3 multiplied by 20 combination 1 multiplied by 25 combination 1 to make up. So this is the third case. So we have 15 factorial all over 15 minus 3 factorial 3 factorial multiplied by 20 factorial all over 20 minus 1 factorial 1 factorial multiplied by 25 factorial all over 25 minus 1 factorial 1 factorial. So this becomes 15 factorial all over 15 minus 3 is just 12 factorial multiplied by 3 factorial multiplied by 20 factorial all over 20 minus 1, and that is just 19 factorial. Multiplied by 1 is still the same thing. So this will be 25 factorial all over 25 minus 1 is just 24 factorial, and then 1 factorial is just that. So I can reduce this to be 15 times 14 times 13 times 12 factorial all over 12 factorial multiplied by 3 times 2 times 1 multiplied by 20 multiplied by 19 factorial all over 19 factorial multiplied by 25 multiplied by 24 factorial all over 24 factorial. So I can just reduce the expression. 12 factorial cancel 12 factorial. So 6 times 2, okay, let me just say 2 here 1, 2 here 7, and 3 here 1, and 3 in 15 is just 5. So I'm left with 5 times 7 times 13 here. So 19 factorial cancel 19 factorial. I'm left with 20 at this side, and then 24 factorial cancel 24 factorial. So I'm left with 35 times 13, 35 times 13 multiplied by 20 multiplied by 25. So if I multiply 35 by 13, 35 by 13 multiplied by 20 multiplied by 25. I have 227,500 ways to have made my selection considering this case. So lastly, what I would do is to find ways by which the selection can be made for the university to form the committee that we are asked to form. So let's get the sum of the three cases. So the first case is 498,750. So let's put that down. 498,750 weights. So that will be plus 630,000. That's the second weight. That's the second case. And then the last case is 227,500. 227,500 ways. So when we find the sum, so we have 0, 5, 2, remainder 1. So this is 15, 6, remainder 1. So this is 13, 15, remainder 1. And this is 12 plus 1, and that is 13. So altogether we have 1,356,250 ways by which the selection can be done. So among the available set of or category of people in the university. So our final answer to the question is 1,356,250 ways. And this is our final answer. I hope you understood everything we did in this video. Pause the video, watch again carefully, get all that needed to be done, get them in your memory, and solve more questions of combinations. Bye bye. See you in the next video.